Okay, Kevin Harms, Performance Engineer, Argonne Leadership Computing Facility, who works on storage and I/O. That was just incredibly simple and elegant. Ladies and gentlemen, Kevin Harms.
All right, so today I'm going to be talking about an upgrade we did on our Lustre file system to take it from Lustre 2.5 to Lustre 2.7. So to give a little bit of an introduction, we started with, this is a Cray Sonexion 3000 system, and it was running the Neo 2.1 software stack, so that's Seagate Lustre 2.5, and then we wanted to upgrade it to the new Neo 3.0, which is Intel Lustre 2.7. That also has a whole new OS, like new kernel, all those things, and then it included the disk and enclosure firmware. So the second thing is, why would we want to do this? Our existing 2.5 system was running well, but we are interested in testing out some of these new features that are showing up in the later releases. And so definitely we want to experiment with D&E. So we're going to plan to try that out. But also we're interested in these future features, especially project quotas. And so we hope to keep moving forward. Lastly, for those who don't know the ALCF well, we are a big GPFS house. We've used it for a long time. In 2016, we installed this Cray system with Lustre, and this is our first experience in Lustre, as well as our first experience with Cray and our first experience with Intel. And so based on all these factors, this upgrade is, I would say, conservative. I'm guessing people who have done upgrades before would not be as conservative this if they have experience, but due to the previous that I mentioned, we went for a much more conservative approach. I'm presenting today, but most of the heavy lifting was done by Gordon McFeeters, who's our lead file system administrator. He's here, so if you want to know more about this, ask him. Also want to point out Tom Jabis from Seagate, who helped develop this upgrade process, and also Dave McMillan from Cray, who worked on our validation process. And then finally, I'm sure there's many people at Intel, Cray, and Seagate that I don't know who contributed much of the work of this before we saw anything. All right, I'm going to start with just a short overview of the hardware we have. This Cray XC40 that we have is called Theta. It has 3,600 compute nodes. All of the compute nodes are Intel KNLs. We're running 30 LNet routers. These are all FDR InfiniBand connected, and these are running the Cray Lustre 2.7.1. We also have 60 more. There is the same hardware, but they're using DVS, and these are running GPFS. Here's some more details on the Cray Sonexion. Each scalable storage unit is 2 OSSs, and then we're using the grid RAID setup, so you have all the drives are in a declustered parity configuration, and so then you just have 1 OST per OSS. So we have 28 SSU, so in total we have 56 OSTs. We have 2 MDS servers. We're only using 1 now. Like I said, we hope to experiment with D&E in the future, but right now we're just using 1. And then this is approximately a 10 petabyte file system, but the amount of data that was on it during this upgrade was significantly less. I know this, no one can read this chart, but one of the things that I think is maybe, I don't know if it's unique, but maybe perhaps different from our installation, we have a 648 port InfiniBand switch that we already had, so we want to continue using that. And so this yellow box in the top is a switch, and then these green columns in the bottom is the storage arrays. And so the storage arrays, instead of top of rack switches, are hooked into these line cards. And then in the left here, these pink and blue boxes represent the I/O nodes. So in this case, the LNet routers. They're plugging into the same leaf switches. So we still have the same fine-grained routing setup that you would find on other installations, just using a switch. And then the DVS routers are assigned their own switches or line cards. I just put this in for reference. This just shows how our storage fabric interconnects with our other systems. So Theta's out there on the edge there. All right, so now I'm going to talk about the upgrade process. So in this case, no on-disk data structures are being updated. So the chance for data loss is very small. However, like I said, we went a very conservative route. So to kind of start things off, we collected some baseline performance numbers to use as comparison to our post-upgrade, and I'll show those at the end. We then switched the Lustre to be read-only, and so then we did 2 stages, which was we generated the list of files on the system, and then using that list, we ran some simple checksums. So we had approximately, if you can see here, 46 million files, and so this process took about 110 minutes, and then we used this simple checksumming program. Now, we just used ByteSum, which is a weak method for checksumming data, but it's also very fast, easy to parallelize, and since we're not assuming the chances for something like this would not detect, for example, if 2 blocks were shuffled, the offsets became different because the sum would still be the same. But if somehow just entire blocks went missing and they became zeros, we have a reasonable chance of detecting that. And so we just went with the simplified weak checksumming method because we felt that it was reasonable. We didn't benchmark this significantly. So we got it to running about peak rates of 150 gigabytes a second. So we felt, oh, that's good, let's go with that. And so this took about 2 hours. So combined, we have a little under 4 hours total to do this work of collecting this data to use in the validation. All right. So now I want to take a small aside. Like I said, the total data amount we had here was under 500 terabytes and only 46 million files. So if we kind of look at an actual real file system, this would be data I took from current numbers from our Mira main file system that's about 5 years old. So we have 1 billion files on there and 15 petabytes. So using the performance numbers from the previous slide, this would take almost 2 days to scan and a day, more than 1 day to do the checksum. So that would mean you're spending 3 days to check before and then 3 days after. I think if we had to do that, we probably would not have gone that route. We probably would have done some kind of sampling and tried to cut this time down unless we were really concerned with some kind of data integrity issue. But because we had this small size, we actually, before the upgrade started, we spent time shrinking the amount of data we had on here to make this process easier. All right, so going back to the upgrade. So all of that were pre-steps. So now we're into kind of the actual process of running this upgrade. And so for step 1, we just go on the Sonexion and we're just auditing the data there to make sure that nothing's unexpected and to clean up anything if it was there. Then we're just going to capture our kind of site-specific configuration information to keep for reference. As I was talking about before, our IB subnet, it's critical to make sure the subnet manager is disabled. You don't want your network administrator rioting if this comes back online and the SM starts up. you back up all the Puppet configuration files, you back up all your network configurations, and then you can unmount Lustre. So this just took about 60 minutes. So now we move into the conversion process. So in this process, Seagate provides you this OEM server, which has a whole software stack on it, and they give you this is going to be used to upgrade your system, and then they take it away. So we previously, before we started, we've integrated this onto our network so it can access all the Sonexion machines. Then you dump the configuration database into some backup, you load that backup to this OEM server, and then you start this conversion process to configure the system. Bulk of this process is done by automated script, so you're basically just sitting there watching it happen. And so all the re-imaging and running, this took about 2 hours. So far, it's pretty time efficient upgrade. Now, once all of that is completed and all of your servers are rebooted, and kind of move into the final steps of completing this and then validating. So there's a short step where you just have to reassemble all the RAIDs, which is just scanning the super blocks, I believe. We were using quotas, so we turned quotas back on. And then you can also optionally, these are kind of in any order down here, but you can collect all the configuration again that I talked about before to use as reference for comparison. And you can just validate that your LNet configuration matches. And then here, you can start up the HA system and then verify everything's running. At this point, this conversion's done and you're pretty much good. But then we moved on to flashing these firmware upgrades. So again, this is kind of a basic process of, running this thing, flashing some devices, running it again. And so that process probably took 2 to 3 hours. Then we see down here, the total time to complete all of this took 9 hours. And obviously the firmware flashing took time, but we ran into significant problems with LDAP, which is probably the least technically interesting thing to discuss, but this always seems to be the bane of our existence, and it took a long time to resolve this, which the resolution is just you enter the right input to the right command, but figuring out exactly what that input was took some time to get the system to respect our LDAP. Then on top of that, I think this was an interesting step. We wanted to make sure that once we had this configuration, that it was actually sticky. So when all of our support from Cray and Seagate left, and sometime later we had to reboot these things, that they would work. So we just went through the process of doing a reboot of all of the servers to validate the configuration was still good when they came back up, which it wasn't because we were still fighting this LDAP problem. So that's where you find out something isn't right. So I would say a takeaway from this is a good step if you do some type of configuration change like this to validate that you actually have it stored. Okay, so finally moving on to the validation. So we can mount the volume read-only. We're going to run this checksum program again. We're going to use the initial input that we generated the first time from the dump LSF entries, run that, and then we're going to diff the outputs. And then we diffed them, they were 100% match. Then you can run the dump LSF entries again to validate that there's no either new or changed or somehow unexpected files, and those also matched. And then, so at this time, we're done, and then we just need to run the performance tests. So I'm going to kind of review the summary of our performance. So I kind of apologize for this in advance. We were running up against some time limitations, so our performance validation wasn't as rigorous as it should be. So I'll just give you some of my opinions about this data. So in the first case, the first IOR, labeled IOR-A, is kind of like an optimized input setup to get the best possible number. We were not able to run this exact configuration right before the upgrade. So in this case, we're actually comparing it to data we took in January. So obviously there's the chance that various things changed, but the post numbers of hitting 230 gigabytes a second was well within our expectations, so we're happy with that number. Moving on to the IOR-B configuration, this is similar, but we're just using many more processes, so this is a tougher workload. Again, the post numbers look good, in line with our expectations of hitting 150 gigabytes a second. Then we tested the metadata server, so we ran mdtest, and I just picked out 2 of the stats that come out of mdtest for creates and removes per second. We see an improvement in the creates per second, but I've run this several times over the course of history, and so 23,000 is right in the ballpark of what we'd expect, so that's good. Removes per second, there can be some variance, so even though we look lower here, we're still happy with this number. So far everything's looking good. The last test case is HACC-IO, which is a IO kernel that kind of simulates the IO that HACC does. In this case, we're down about 20% on the throughput for write. And I did run this a couple times, and it's still, this is actually lower than we would expect. So some investigation needs to be done on my part to try to figure out exactly where this lost bandwidth is. Is it just a configuration difference between the 2 runs, something with the nodes chosen? So I need to go back and try to look at that. But overall, we're looking good. So in conclusion,
Waiting for the conference host to join. If you are the conference host, please enter the conference PIN number now. Waiting for the conference host to join. If you are the conference host, please enter the conference PIN number now. Welcome to the conference.
Conservative in the approach you took, but obviously you're a lot more experienced with GPFS, and I just wondered how both the amount of planning and the actual clock time to complete a major upgrade like this would have been with GPFS that you are more comfortable with.
So to compare and contrast, normally in GPFS we would do most of the planning. In this case, this was handled by Intel, Seagate, and Cray. They did a lot of the work for us in the pre-planning stage. So they kind of delivered us a working thing. We just had to test it. And then the total process time here was about 6 days. I didn't mention, like, when we completed basically the conversion, we handed back the system to the users just without Lustre so they could run on GPFS. And then that kind of elongates any time because you can't just if you want to test something right then, the maximum wall time on Theta is 6 hours, so you're waiting a minimum of 6 hours to test something. On GPFS, we have many more test systems. So, they're running kind of production, but we're not as worried. So we would just go and do the upgrade on our test system, and if it exploded, we would not do it on our primary production system. So we're there probably less cautious because we kind of know more, and that's a system that we have a system that's reasonable facsimile of regular GPFS, and we can just apply the changes there and do, a minimal planning.
Okay, and the actual, so basically you would just go into it, you're much more familiar, and you would just try it with a smaller system and ramp up.
Yeah, so we have a system called Vesta, and it has basically the exact same hardware, runs the same software. So it's a perfect twin. It's just smaller scale. So we have done GPFS upgrades and then had like a scaling issue where some difficulty shows up that we didn't see before, which is, I'm sure everyone has seen that happen. But yeah, in general, can do a lighter amount of planning.
Okay, thanks.
Anyone else? Oh, in the back. Oh, sorry, Scott, great.
Or here. Hi, I have two questions. The first one, I really like the timing you took, and I was wondering if from the test you did on the TDS and the real timing then you got on production, the time was scaling linearly from the small one. I suppose you have a small system as TDS.
Yeah, it was two SSUs. I believe so. We didn't take detailed timing on the TDS system. So the main kind of cases where you have expansion of the timing is the number of servers to image. So instead of 4, you have 56.
And then the other one I'm wondering is, as you are, we are a massive user of GPFS, and we are asking Cray, Seagate, and Intel to produce some of rolling upgrade for Sonexion. Are you doing the same, pushing in the same direction?
So far, I'm speaking maybe more for myself in general, but we haven't done much in the rolling upgrades. We've typically just do it on our maintenance time, and then we'll just upgrade so we might know this will take 3 hours, so we do 3 hours worth of work. So if that's upgrading some number of components, we'll just do that number and then do the rest in another cycle and another cycle.
So this means you foresee to keep the two different file system alive because you won't do a maintenance for 6 days. Am I right?
That's also true. I mean, we would anticipate, Theta right now only has, the end goal of the configuration would be to have a primary GPFS file system and a primary Lustre file system. So yes, you could afford to take downtime and have the other file system serving the system.
Anyone else? Okay.